Good morning, everybody. Welcome to overcast, not sunny, overcast, rainy, real rainy Friday morning. It's Friday. Yay! We get the weekend off. Don't forget, there's only 1.5 or today and tomorrow shopping days left till Halloween. All right, let's go through a couple things. One, make sure you're handing in your labs. You don't want to lose points, so hand in your labs. All right, and to Ruben, thank you. Good morning to you and everybody else. All right, let's get going. Today I said I would go through chapter 6 problem set. So Dr. White keeps his word. Now, let me move something out of the way. All right, thumbs up, people. Everybody see chapter 6 gas law problems. Thank you, everybody. All right, let's go through this. Now, the first one, how many torr is 41.5 mm Hg? That's millimeters Hg is mercury. So we're trying to find torr. We're given millimeters of mercury. And here's what I start with. Here's what I'm trying to get to. I'll use my good friend, my good buddy, unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. Now, I have here 1 torr per 1 millimeter mercury. You could have also put in 760 and 760. And where would you get that? If you look at important information, test number 3, here's the relationship between torr and millimeters of mercury. If you notice, if you divide both by 760, 1 torr equal 1 millimeter of mercury. Now, these are all exact numbers. So that means whatever you start with, that's how many significant figures you should end up with. Remember, test number 3, like 2 and 1, underneath where it says you print your name and sign it, it will say, please use proper significant figures for all calculated answers. And time for a commercial from Dr. White, me. Test number 3, show your work. If you have a, say, 15-point problem, 15 points, and you just put down the answer, it's not one of the 2 answers or the answer that's correct, I'll give you 0 points. If you show you all your work and you made some sort of mistake over here or math error, your calculator, I'll only take off a couple of points or maybe only 1. So show your work on the test. It's to your benefit. So this is 3 significant 3. Now notice on number 2, how many millimeters of mercury is 1,425 torr. This is 4 significant 1, 1, using analysis to get this ratio, and you get the same thing. Now, let's take a look at number 3. How many atmospheres is 741 torr? Well, how do you proceed? Well, what are we asked to find? Atmospheres. That's what ATM stands for. And you're given the number of torr. This is what you start with. This is the units you're trying to get to. Using unit analysis, if I have a ratio that I can convert torr to atmospheres, what goes on top of this ratio? Atmospheres. What goes underneath? Torr. Where do I get the numbers? Well, if you didn't memorize it, good news, it's an important information. 760 torr equal 1 atmosphere. And those are both exact numbers because that's the definition. So if we do the math, you round this off to 3 significant figures. And notice, oh, someone was nice enough to even write down, note, 1 atmosphere, 760 torr equals 760 millimeters of mercury. Now, if we look at number 4, but first, time out for a tea break. Oh, that blueberry tea is good. We're trying to get to torr, and you're given atmospheres. So this is the only number we have to start with. We're trying to get to torr. Torr goes on top of this ratio using your good buddy, your good friend, unit analysis, and atmospheres goes underneath. Now, where do we get these numbers? Well, I have it written up here. It's also important information. 760 torr equal 1 atmosphere. These are exact numbers. Notice this is 4 significant figures, and my answer is 4 significant figures. Now, the next one, number 6. If a balloon has a pressure of 658 torr and a volume of 1.894 L is liters, volume measurement, what is the pressure of the balloon if the volume is increased to 5.133? So if we look over here, what are we being asked to find? The pressure after you make a change, which is the final pressure in this problem. And I'm going to call that P2. And what are we given? The initial pressure, P1, 658 torr. The initial volume, 1.894 liters. Liters is volumes. Now we're asked, what's the final pressure if the volume is increased to this new volume, 5.133, and that's final volume. And what do? We're dealing with a balloon and pressure and volume, that's gas. And if you look at important information, test number 3, in the past, I'd have students memorize this. You don't have to. It's Boyles Law. And Boyles Law deals with only pressure and volume. And it's P1 times V1 equals P2 times V2. And the initial pressure is P1. The initial volume is V1. The final pressure is P2. The final volume is V2. So what are we going to use? Boyles Law. P1 times V1 equals P2 times V2. Now we want to solve for P2. We figured that out. So how do I get rid of V2 on this side? When you're multiplying 2 numbers and you want to get rid of one, divide by that number, because anything divided by itself is number 1. 1 times something else is that something else, in this case P2. But whatever you do to one side, you have to do to the other. So I did. I divide this side by V2, this side by V2. And V2 divided by V2 is 1. 1 times P2 is P2. And the other side is still P1 times V1 over V2. And now I rewrite it. You don't have to. And we took the time to find out what is P1, V1, V2. I'll put those numbers in. And notice this is 3 significant, 4, and this is 4. When you multiply and divide, you get the same number of significant figures in your answer as the number that has the lowest significant figures. In this case, 3, 4, 4. I hope you all agree 3 is the lowest number. So my answer has 3 significant figures. Now I'm going to try something different. If everybody, can you see problem 7 at the bottom of your screen? Give me a thumbs up if you can. Thank you, Amber. All right, why don't you read problem 7, find out what are you being asked to find, what are you given, and then whose law, and just solve for the variable you're trying to find. And it's your turn to have fun. And when you're done, I'm not asking you to solve everything. Just figure out what are you being asked to find, what are you given, and what equation do you use, hint, and solve for that variable. And that's all I'm asking you to do now. And when you're done, give me a thumbs up. And it's important you try, because this is a time, if you're having problems, you should find out so you don't have them during the test. Makes sense, doesn't it? Actually makes good points for your test score. While you're doing that, reminds me one of the greatest mentors I ever had when I was in industry, Sid Shapiro. When I was just starting out, he was like, oh, at least 35 years older than I was, but he took me under his wing, so to speak. He used to always tell me, common sense is not common. Thank you, Gabby. I figured I'd use the poll instead. All right, I think everybody's done. So let's see if you did it correctly. So number 7, if a piston has a volume of 22.4 liters at 12.34 atmospheres, what's the volume of the piston when the pressure is reduced to 3.567? So what are we being asked to find? The volume, the final volume, V2. We're given initial pressure, P1, actually initial volume V1, 22.4 liters, and initial pressure of 12.34. Now the pressure is changed to 3.567, which is the final pressure. So we're going to look at this problem and say, oh, it's dealing with a gas, because I'm talking about pressure, atmospheres, and volume. I only deal with volume and pressure. So I'm going to use Boyles Law. P1 times V1 equals P2 times V2. Now, what are we being asked to solve for? V2. And if I look at this, I say, oh, I want to get rid of P2. If P2 times V2, and I want to get rid of P2, I can divide by it. Anything divided by itself is 1 times V2 would be V2. But whatever I do to one side, I have to do to the other. And I did. And now V2, because P2 over P2 cancel out, become the number 1. V2 equals P1 times V1 divided by P2. Now, I like to rewrite it. You don't have to, but I do. And I did. And now I was running out of space, so follow the arrow. And we have V2, and I put in what is P1, V1, and P2. Notice I didn't do the last problem bad, Dr. White. Atmospheres divided by atmospheres cancel out. I'm left with liters. And here, notice this is 4 significant, 3, 4. My answer is 3 significant figures. And that's how you do it. Now, next thing I'd like to talk about is my favorite mathematical equation in chemistry, the ideal gas law, PV equal nRT. Now, P is pressure, V is volume, N is moles, R is the universal gas law constant, which is 0.0821 atmospheres, liters, mole K. That's a calculated number, and the one we use, I use, and you'll use is 3 significant figures. And this is PV equal nRT. By the way, don't forget, with winter coming up, when it gets real cold, if it does this January and February, which hopefully it will, not that I want cold, but at least maybe we'll undo global warming. If the temperature goes way down and this and this and this are kept constant, your car tires, your pressure goes way down. So PV equal nRT tells you in the winter, check your car tires. And in the summer, just the opposite is true. And that is you still should check your car tires, but in the summer, the temperature goes up and R and V stay the same. Therefore, the pressure will go up. And I think I mentioned it back in the summer of, I hate to ask this. I hate to ask this, boy. How many of you, give me a thumbs up if you like, how many of you were born after 1995? All right, I shouldn't have asked. Boy, next thing you're gonna tell me, you're old and you've got gray hair and you're missing. Oh, I am. But anyways, back in the summer of 1995, we had a brutal heat wave here in the Chicagoland area. And when I worked at a company located east of Great America in Gurnee, I'd have a long commute on the interstate. And in the morning or coming home in the late afternoon, you'd see cars and trucks pull over. You see pieces of rubber all over the road. They had a massive blowout. That's because the temperature was so hot, the pressure in your tires expanded, and like a balloon that you blow up too much, boom, it blows up. Luckily, I was never near one when it happened. That would shake you up a little while you're driving. But anyways, I guess if it happened to you too, it'd also shake you up. Remember, PV equal nRT teaches you when you should be checking your car tires. Or if you don't have your own car, help out a friend, neighbor, loved one, remind them. All right, let's look at let's skip number 9. Let's go to 11. And let's read this, or let me read it. A tire, and you can read along. Am I nice or am I nice? That was awful. Anyways, a tire contains 25.67 grams of nitrogen gas at 26 degrees C, 705 torr. what is the volume of the nitrogen gas in the tire? So what are we being asked to find? A volume. We're given the weight of the nitrogen, the pressure in torr, and the temperature of the gas in the tire. And notice this only deals with pressure, grams, volume, and temperature. Nothing has changed. Now, there's one thing that's missing from here that I'll put down that you would see on a test. Hint. Yep, it's a lot of work, so it should be a lot of points. Let's go through how you do this. All right, you need to use the ideal gas law. And what are we solving for? Volume. Therefore, we want it alone on one side. PV equal nRT. And again, that's an important information. And to get volume alone, I have to get rid of the pressure P. So I'll divide this side by pressure. And I'll divide whatever I do to one side, because pressure divided by pressure, anything divided by itself is the number one, and 1 times V is V. But whatever I do to one side, I have to do to the other. So I will. So V equals nRT divided by P. Now let's go back to important information. Remember, you will be given this. Pressure for PV equal nRT has to be in atmospheres. And it's time for a public service announcement from your host, me, Dr. White. One of the most common mistakes on test number 3 for this type of problem is the student uses the pressure in torr or millimeters of mercury. No, it won't work. And I'll take off points because it's wrong. You need to convert to atmospheres. And the same thing for temperature, and also N is moles, and you're given it in grams. So you have to do the conversions I'm going to be showing you. So if we look over here, the first thing is we need N. N is moles. Where do you get that? You get that from important information, test number 1. And how do we go from grams of a compound to moles of a compound? Well, you use your, I haven't done it all morning. Hold on, here it comes. Use your good buddy, your good friend, unit analysis. Ooh. And whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. Where do you get a relationship between moles of a compound and grams of a compound? Oops, I just see a mistake. The 2 over next to the end here fell off. If you can see it on the page somewhere, let me know, I'll put it back. That was an awful joke. But let's go to important information, test number 3. And right here, in case you forgot from test number 2, 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of that compound is the sum of all atomic weights. And I don't have something open, so I've got to open it. All right. And as you see, the periodic table we've been using all semester. If you look here, you'll see that the atomic weights are underneath the symbol. On test number 3, just like test number 2, it will say, please use proper significant figures, not for all calculated answers. It will say that. Underneath that, it will also say, like test number 2, please use atomic weights to 3 significant figures. If you don't, I'll take off a point. And for nitrogen on the periodic table, it's 14.007. I'm going to let you round that off to 3 significant figures. And the answer is 14.0. Keep the 1, keep the 4, keep the 0, use the next 0 to round off. That's 4 or less. I dropped the 0 and 7. That's 14.0. So now the molecular weight of nitrogen is 2 times 2 nitrogen, because nitrogen, I was nice enough to give you, is N2, and 2 times 14.0 is 28.0. And here you do the math. This is 4 significant figures, mole, 1 mole, the 1 is exact number. And here we have, oh, my favorite, 3 significant figures. So the final answer is 3 significant figures. All right, now we have N. R will be given to you, where important information, test number 3. And you don't have to memorize this. Remember, this is 3 significant figures. All right, so we have N, and now we have R. What's T? T is temperature, but temperature has to be in Kelvin. Oh no, I gave it to you in Celsius, which I always will. And if we go back to important information, test number 3, let me clean this up a little. Notice right here, Kelvin equals degrees plus 273. This is an exact number. Now, in this one, if you make the following, which I didn't here, and you can, I will never take off points. Well, actually, I did it right. I always forget this is the one area even Dr. White has to think about it. That's addition. Addition, you get the same number of significant figures to the right of the decimal as the number that has the fewest significant figures to the right of the decimal. And this sometimes, like I just said, throws me for a loop. And if we look at this, 26, how many significant figures does it have to the right of the decimal? None, 0. Add it up, you get 299. You don't change this to 2 significant figures. You look at how many significant figures to the right of the decimal, and the answer is 0. And this has 0. Even though it is 3 significant figures, that's how you do addition. So I have N, R, T is now in the right units, and we're left with pressure. And now if I look at this, pressure should be in atmospheres. In case you forgot, it's in important information, test number 3. In the ideal gas law, P, pressure, has to be in atmospheres. Well, I didn't give it to you. I have never seen a gauge measure pressure in atmospheres. It's usually in torrs or millimeters of mercury. And in this case, I gave you torr, so I now have to do this in pressure, or change it to atmospheres. I have 705 torr. I want to get to atmospheres. I'll use my good buddy, my good friend, unit analysis to convert to atmospheres. Whatever goes, if I can use a single ratio to convert torrs to atmospheres, atmospheres goes on top, torrs go underneath. Where do I get these numbers? 760 torr equal 1 atmosphere. It's an important information. Test number 3. Boy, are you guys lucky. In the past, about a year and a half, 2 years ago, before I started providing this, students would have to memorize all this. But you don't. I'm going to test your chemical skill, not your memory. Well, some of your memory, you got to know how to use this. And 1 atmosphere is 760 torr. And therefore, 1 atmosphere is 760 torr. These are exact numbers. 3 significant figures, 3 significant figures. Now I put all the numbers in. Notice moles divided by moles cancel out. Forget about the bottom right now. Kelvin divided by Kelvin cancels out. This is gone. Now let's look at the bottom. Atmospheres here. On top would be atmospheres. That cancels out. We're left with, yay, liters. So I do it. 3 significant figures, 3, 3, 3, 3, 3. And notice it says both ways. What that means is in the past, or not in the past, what am I saying? Well, it was in the past too, but there are 2 ways of rounding off at each step for each calculation, or wait until the end. Dr. White is an each step person. I am, but I'm not going to force you to do my way. No, I'm not going to force you. And I'll calculate it either way. In this case, if you round off the end or at each step, it's the same answer. If they're different, both will be correct on test number 3. Am I nice or am I nice? Don't answer that. All right, guess what I didn't put in here? So first, let's look at important information. And Dalton's law of partial pressures, the total pressure is equal to the sum of the partial pressures of all the gas in a mixture. P total equals the sum of all the partial pressures. Partial pressure is the pressure of a gas if it was alone in that mixture. So I'm going to give you one to try out. I keep wanting to write, and I figure this is the class printing. And this is your turn. I'm going to let you try this all on your own. But in case you forgot, and it's your turn. Have fun. And it's time for you to vote. All right, I think everybody's done. I better get to work. So the question is, a mixture of argon and nitrogen has a total pressure of 751 torr. And the argon partial pressure, P sub AR, is equal to 111 torr. And what are we being asked to find? The partial pressure of nitrogen. And if you notice, we're talking about partial pressures. As soon as you see the word partial pressure, you think of Dalton's law of partial pressures. P total is the sum of the partial pressures of all the gases in that mixture. So in this case, P total equals partial pressure of argon plus the partial pressure of nitrogen. Now, what am I being asked to find? This. Uh-oh, this is in the way. Now, when you're doing addition, how do you get rid of a variable? Well, A plus B, if I want to get rid of A plus B minus A will be equal to B. So I have to subtract that variable. So I want to get rid of partial pressure argon. I will subtract partial pressure argon. But whatever you do to one side, you have to do to the other. Now, anything minus itself is the number one, or is zero, I'm sorry, and is canceled out. And because I like to, you don't have to, I'm going to rewrite this. And now I know P total is 751. And P argon, partial pressure, is 111 torr. I'll pick up my calculator or do this in my head. And that's our answer. Now, I haven't talked about it, but subtraction is just like addition. You get the same number of significant figures to the right of the decimal as the number that has the fewest significant figures to the right of the decimal. And that's chapter 6 problem set. Again, I highly recommend, or even more strongly, I highly urge that you try these on your own. Don't look at the answers first, just try it. Try and find out what's the variable you're being asked to solve for, what are you given, and then you can look at test number 3, important information. It's in the lecture folder of Blackboard. And guess what? Try it. I won't say you like it, but I hope you do. But it will help you on test number 3. If you try those problems, they're practice problems for a reason. Hint, hint, wink, wink, say no more. That came from Monty Python and the Flying Circus. You've never seen Monty Python and the Flying Circus? Boy, are you missing something good. All right. Now, we got a couple minutes. I was thinking, what can I do today? Something special for you. End up the week on a real bang. I'm thinking, let me do something that will not be on test number 3 or 4, the final, but might be useful to you. And what is that? How to solve a problem in real life. One of the things I've been blessed with is throughout my career and my life in general, but especially my career in the chemical industry, I've been very good at problem solving. In fact, I've been asked to solve problems that were not even my problems to begin with in the area I was responsible for in a company. And what's the first good, important thing to do when you're trying to solve a problem? Desire. And with that, have a great weekend. Gang gesund. Goodbye.